This is the second trig lesson in geometry, and this one focuses on similar figures. This one doesn't use the trig ratios in the new lesson, but it's in here because similar figures use proportions, which, if you remember, are two equal ratios. So I'll talk about that when we get there, but just to review a little bit of what trigonometry is, we'll start with a couple multiple choice refresher type things. So first, if we're looking at the sine of A, because it says A, we want to stand at A and then label our sides. So this one is the opposite, adjacent, and then across from the 90, this is the hypotenuse. So the sine of A is so opposite over hypotenuse. So 20 over 52. This reduces to 10 over 26, which reduces to 5 over 13. So that would be B. The cosine of A, again, if we're standing at A, we're going to label this op height because it's across from the 90 degree and this one's adjacent. I'll just tell you the missing side is 48. You could do the work to find it, but just to save time. Cosine is ca, adjacent over hypotenuse. So adjacent over hypotenuse is 48 over 52, which reduces to, let's see, divide that in 2 is 24 over 26. Divide that in 2 is 12 over 13. So be this guy. Tangent, so I just told you that's 48. Tangent of A again, so we're standing at A. This would be our opposite, hypotenuse, because it's across from the 90, and then this is adjacent. Tangent is TOA, opposite over adjacent, so 20 over 48. Which is 10 over 24, which is 5 over 12. So this guy. We'll just do one of these. Sine of B, that's B. So we're going to name this one opposite, because that's opposite. This is our height, whoops. And this is adjacent. Sine is so opposite over hypotenuse. And remember, that one's 48. So 48 over 52, which is 24 over 26, which is 12 over 13. All right, that's enough of a review, but it depends. The angle that you're at is going to change the result. Just keep that in mind. Okay, so similar figures are two figures that look the same, but just maybe are bigger or smaller than the original. So if you'll notice, this shape and this shape look the same. It's just this one's been amplified. It's been made bigger. This one and this one look the same. It's just this one's been made smaller. So if I was going to blow this side up, it would match up to that side. If I was going to blow this one up, this would match to this. Okay, they're not actually equal, so my markings are incorrect. But it just means that those are kind of corresponding sides. These two do not look the same. If I made this one bigger, it would not look like this. They are not similar. Same here. This one's got a super little top and a bigger bottom. That does not have a little top and a big bottom. So those are not similar figures. So to find similar figures, what I do is I find two sides that I have both numbers for. So two corresponding sides for which I have both numbers. Two corresponding sides for which I have both numbers. That would be that and that, for example. This side and this side would be the same if it was expanded. So that means, actually, this one's a lot easier than it looks. We need to find x, y, and z. Notice how this side and this side are marked the same. They both have one tick. That means that x is 4. And since these are similar figures, if these two sides are equal in the original, these two sides will be equal in the new one. And then this is where we need to do a little bit of work. So this side and this side are corresponding. That's z and 21. So what we need to do is take the 4 over 14 and set it equal to z over 21, because those ratio of side lengths need to be the same. And then if you think back a couple of units, cross multiply, you get 84 is 14z. And then if you divide by 14 on both sides, I believe we get 6. Yep. So z equals 6, because these chunga chunga. All right. So again, we need to find two corresponding sides for which we have both numbers. So this side corresponds to this side, and look, we've got both numbers. So what I would do is take 12 over 3 needs to equal, I don't know, let's find x first. X corresponds to 4. So 12 over 3 is the same as x over 4. Cross multiply. Divide by 3, divide by 3, chunga chunga, x equals 16. Now what you might notice, you guys, is that, look at this. This is 4 times bigger than the original, or the smaller one. That's 4 times the size. 4 times 4 is 16. 3 times 4 is 12. So that means 6 times 4 is going to be this one, which is 24. But if you don't recognize that, it's fine. We're going to take these two corresponding sides. So 12 over 3 equals y over 6. 72 equals 3y. Divide by 3, divide by 3, chunga chunga. We get 24. Again, what I'm saying is this shape is 4 times the size of this, because 3 times 4 is 12, and 4 times 4 is 16, and so on. Oops. Sorry, I meant to write 24. Okay, so starting here, we need to find x, y, and z, but we need to find two corresponding sides for which we have both lengths. This corresponds to this, but that's a z and a 30, no good. This and this correspond, but that's an x and a 16, no good. This and this correspond, that's good. We have the 8 and the 6. So 8 over 6 needs to equal, let's do x first. 8 over 6 is 16 over x. Cross multiply. 8x equals 6 times 16. 6 times 10 is 60. 96? Let's see. 96. Divide by 8. Divide by 8. Chunga chunga. X is 12. Okay. Next one, let's find y, because it comes next. So 8 over 6 equals y over 7. 56 equals 6y. Divide by 6, divide by 6, chunga chunga. Y is 9.3 repeating. And then last we'll do z. So z is 8 over 6 equals 30 over z. 8z equals 180. Divide by